Good morning. Today we're going to look at vector quantities. Vector quantities are very important in physics. Vector quantities have both magnitude and direction. As you can see in the picture, a vector is represented by a line with an arrow. The length of the line represents the magnitude or size, while the arrow shows the direction. So that's a vector. It has both magnitude and direction. There are many quantities in physics that are vectors. Displacement, velocity, acceleration, force, and momentum are a few vector quantities. Now, the other type of quantities are called scalar. Scalar quantities only have magnitude. They have nothing to do with direction. Examples are mass, time, length. Length could be distance. So there are only two types of quantities, either scalars or vectors. Now, in this chapter, we're going to look at vector quantities. We're going to chiefly look at how to multiply a vector with a scalar. We'll look at how to add vectors or to find the resultant of two vectors. The multiplication of two vectors can be done in two ways. One is called a dot product and the other is called a cross product. So these are the things that we'll look at as we move forward. So the first thing is, as you look at this picture, you see that to go from A to B, there are different routes that can be taken. So along the dotted lines, you can go along any one of those dotted lines from A to B, and that is called the distance. When we take the paths shown along the dotted lines, we are not moving in a specific direction. So distance is a scalar. On the other hand, if we draw a straight line from A to B with an arrow, as shown in the diagram, that is a vector because we're moving in a specific direction. And do you know what that is called? That's called the displacement. So you have distance and displacement. And all the time, displacement is going to be shorter than or equal to the distance between the 2 points. And displacement is always the shortest distance from the starting point to the finishing point, which also means that if an object returns to its starting point, like when you throw an object up from the ground and it returns to the ground, its displacement is 0, while the distance traveled is not 0. It's something. It depends on how high it went, multiplied by 2. So that then is the difference between distance and displacement. There are many types of vectors. I'm going to go through this very fast. You see, there are two vectors that are parallel to each other. They are not equal, but they are parallel. In B, again, these two vectors are not equal in magnitude, but they are anti-parallel. In C, the two vectors are equal in magnitude, but opposite in direction. So that's why it's given that A is anti-parallel to negative A. D, the two vectors are equal. So A is equal to B. And E, A is orthogonal to B because the angle between them is 90 degrees. So those are the two types of, those are the many types of vectors that you could have. So moving forward, how do we find the resultant of two vectors? What did I say? Did I say a resultant? Coming from the word result, which means sum of the two vectors. How do you add two vectors? So you see the vectors A and B as given in the diagram. You can move them parallel to themselves and join them to one end and complete a parallelogram because the opposite sides are parallel. And if you draw the diagonal of that parallelogram, passing through the point where the two vectors are, then the diagonal will give you the resultant. So that's one way of adding vectors. This is called the graphical method of adding two vectors. So in this case, you'd have to take a definite scale, and based on that scale, when you represent A and B and complete the parallelogram, if you measure the length of the diagonal and use the same scale, you would get the resultant. That's one method. Now, how do you find the difference between two vectors? That is shown in the last diagram. The difference between two vectors, A minus B, is simply A plus negative B, right? In the first diagram, you see that B and A are drawn exactly like they are. So B and A. And if you join their ends, you will get the resultant. So that's how you find the sum. But look at this diagram. A is drawn just like it is. But look at B. The direction of B, if you can see the arrow here, is opposite to the vector B. So which means it's negative B. So when you add A to negative B, you get D. D standing for difference. So this method is called the end-to-end vector method. So you draw one vector, draw the next one exactly connected to it like that, and then join them, you will get the sum. If you want the difference, then draw the first vector, draw the second vector up in the opposite direction. See? So instead of B, now you have negative B, and then you join their ends, you're going to get the difference, okay? So you got to be careful when you do that. Instead of having it this way, you're going to have it here, and then the difference is going to be here. That's how you find the difference between two vectors. Now, the end-to-end method can be used for any number of vectors, as you can see in this map. You start from this point and start moving. That's vector A, B, C, D, E, all in the flowing direction, same direction. You want to find the resultant of all of these vectors? No problem. Just go to the starting point, which is here, and draw a vector to the finishing point, which is here. And that is the resultant of all of these 5 vectors. It will work for any number of vectors. Do also remember that if the polygon closes, then, the net sum of the vectors is 0. Another method of adding vectors is by resolving the vectors into its components. So as shown in this diagram, if you have a vector A, it can be broken up into its x component and its y component. If the angle is taken with the x-axis, like with this, then the x component is going to be cosine and the y is going to be sine. So if this is vector A, you could have A cosine theta and A sine theta. That's one way of putting it. But we can also use the unit vector method. Now, unit vectors ijk, I is along the x-axis, j is along the y-axis, and k is along the z-axis. Now, these are called unit vectors because their magnitude is 1. So what's the use of these vectors? I'm glad you asked. If you put a vector as 5i plus 3i plus 2k, I just made up the numbers, that means this particular vector has 5 on the x-axis, the magnitude is 5 on the x-axis, 3 on the y-axis, and 2 on the z-axis. So any vector can be represented using the unit vector method, as you can see here. Okay, so how is this going to be useful? It's going to be very useful when you add or multiply vectors. Before that, let me also show you how these vectors are resolved. So here is the resolution of vectors used to add two vectors. We've already seen that using the end-to-end method, you can draw A and then connect B to its end. And then if you join them, you get the resultant, right? Now, we could also use the component method, where that's the x component, A cosine theta of A. And then you have the y component of A, which is A sine theta. Similarly, you have the x and the y of B. So that's the x component of B, and then you have the y of B, where I've taken this angle to be phi. Okay? So once you get the x and the y components of both the vectors, now you add the x components to each other and do the same with the y. So I'm trying to draw that, but remember, the x component is A cosine theta, the y component is A sine theta. For B, it's going to be B cosine phi and B sine phi. And this is true when the angle is taken with the x-axis, okay? So here now, I have added the x components to each other. So you have the first, that's A sub x, that's B sub x. This is A sub y, which is the same as this. They're equal vectors. And then you have B sub y. So when you add the x components and the y components, you can see that you get a right angle triangle. And then we can use the Pythagorean theorem to find the hypotenuse of the triangle. So that's the method. That is the method that we're going to be using throughout the semester. So get used to it. Once you get that, you have this right angle triangle PQR, and then you know that, PQ is AX plus BX, and QR is AY plus BY. And once you get those, you can find the resultant using the P theorem, okay? And also you can find the angle made by the resultant. I call that alpha. The angle made by the resultant with the x-axis. How do you find that? Use tan alpha. Tan is opposite by adjacent. So you get this whole thing divided by this whole thing. Okay? And that's alpha. Remember, tan alpha. So when you find the resultant, you not only have to find the magnitude of the resultant, you also have to find the angle that the resultant makes with the x-axis. So we know we can find the resultant of two vectors either using the graphical method or the resolution method. And again, you can also use the unit vector method to add two vectors. So here is an example of using the unit vector method. So let's say that we're talking about three-dimensional vectors. Therefore, it should have the AX, AY, AZ. And that is represented using the unit vectors IJK. And I'll give you an example of, let's say, vector A is 5i plus 3j plus 2k, 5, 3, 2. Those are the numbers that just popped up in my head. And then B is negative 2i, negative 4j plus 7k. How do we add these two vectors? Oh, it's so simple. Just add the coefficients of I, add the coefficients of j, and the coefficients of k. That's the easiest. So 5 minus 2, 3, plus 3 minus 4 minus j, and 7 plus 2, 9. So that is so easy. That is the resultant vector. But how do you find the magnitude of this resultant vector? Because we just got it in unit vector format. We need the actual number. What do? Simple. Square 3, square 1, because you have 3 here, you have 1. Actually, you have negative 1. But negative 1 square is just 1, And then square 9. So 81 plus 1, 82 plus 9, you will get what? What's that? 91. And if you take the square root of 91, that gives you the magnitude of the resultant. So that's how we find the resultant of two vectors using the unit vector method. Shall we move on? Yes, of course. So here are two vectors, and you can find the components, and I am just working out an example just in case somebody has a little bit of confusion. I'm showing you that sine theta is opposite by hypotenuse, and so using that you can find the y component as 5 sine 30, okay, because this is the opposite side. And likewise, using the definition of cosine, you can find the x component, which is 5 cosine 30. Generally, the x is going to be cosine and the y is sine, because the angle is usually taken with the x-axis, okay. And once you get that, you can take another vector, do the same with that, add the x's together, add the y's together, and then use the p theorem. Okay, we've already spoken about that. So let's move on. Okay, and I've given another example of adding it using the unit vector method. Now, how do we multiply a vector with a scalar? That's quite simple. As you can see, if vector A is 2i plus 3j plus 5k, then so what is 5 times vector A? Just multiply each coefficient with 5, that's all. So 2 times 5, 10, 3 times 5, 15, 5 times 5, 25. Isn't that easy? So multiplying a vector with a scalar is easy. What about multiplying a vector with a vector? There are two ways of doing that. So vector multiplication could either be taking the dot product, dot product, or taking the cross product. I'm going to show you both. But I want to tell you that when you take the dot product of two vectors, what you get as the product is a scalar. The dot product of two vectors gives a scalar, but the cross product of two vectors gives another vector. Okay? So first, the dot product. Let's assume two vectors. Let's say that vector A is 3i plus 4j minus 6k. That's a vector. Vector B is, now this is moving too slow. It's okay. 2i minus 3j plus k. To take the dot product, A dot B, before you take the dot product, I also want to tell you that A dot B is actually AB cosine theta, where theta is the angle between the two vectors. So if you have A like that and B like that and the angle between them is theta, dot product simply means A times B times cosine of the angle, as I'm showing you there, right there. You can do it that way. But using the unit vector method, it's even easier. And one of the best examples for dot product in physics is work. Work is the dot product of force and displacement. Force, you apply a force, something moves, right? And to find the work, you got to find the dot product between the vector force and the vector displacement. So work is a scalar, although it's the dot product of two vectors. Why? Because a dot product of two vectors always gives you a scalar. All right, so now how do you find the dot product of these two? A is 5, B is 4, theta 60. Simple, it's 5 times 4 times cosine 60, which will come out to be 10. Check it out. I've not written it, but check it out. All right, using the IJK method, all you got to do is multiply the coefficients of I. 3 times 2 is 6. 4 times negative 3 is negative 12. Negative 6 times 1, because there's a 1 there, is, ooh, that should be negative 6. I missed that. Let me correct that. Okay. So 6 minus 12 minus 6. Now I got it. That gives you negative 12. See? Just like that. And notice that this doesn't have an I or a J or a K with it. What does that mean? It's a scalar. It's a scalar. It doesn't have an ijk. It has no direction. So once again, the dot product of two vectors always gives you a scalar. That's how you take the dot product. You can do it in two ways. Number one, A dot B is AB cosine of the angle between them. But if the two vectors are given in unit vector format, then just multiply the coefficients of I, of J, and K. Put it as a vector. You want to find the magnitude? Oh, you already get the magnitude because it's not a vector. What you get is a scalar. Okay. So to find the cross product of two vectors, we got to slow down a little bit here. And remember, when you take the cross product of two vectors, you get another vector. There are plenty of examples in physics where you take the cross product, and we'll be using them during the semester. One of them is torque. Torque. Torque is the cross product of R and F. Another example, angular momentum is the cross product of R and P. So there are many examples. But let's look at how to take the cross product of two vectors. So here you have two vectors, A and B, written as AXI plus AYJ. Technically, you got to put a hat on IJK. All right. You got to put that because those are the unit vectors. And to take the cross product, you go A cross B. And let me also warn you that A cross B is not the same as B cross A. One is the negative of the other. So the order when you take the cross product is very important. But not when you take the dot product. Okay, here the order is very important. And we have to put it in matrix form, using matrices where you put I, J, K on top. Then list the coefficients of vector A first because it's A cross B. What are the coefficients? It's AX, AY, and AZ. Then list the coefficients of B. And then to find the cross product, so that's the matrix format. To find the cross product, you put I, and then do not look at what's under I. So block it off. Look at what the coefficients are under J and K. What do you have under J and K? You have AY, AZ, BY, BC. So you're not going to look at these two. You're just looking at these four. And then you go multiply from left to right. So AY times BC minus AZ times BY. Again, AY times BC minus AZ times BY. So that will give you the coefficient of I. And to find the coefficient of J, you got to put a negative. That's just for J, and I'll tell you why shortly. Minus J, block off what's under J, which means you don't look at these two. Now look at the other four. And similarly go AX times BC minus AZ times BX. Same idea. AXBZ minus AZBX. Plus K, block off what's under K, so that'll be AXBY minus AYBX. So that's how you find the cross product of two vectors. Let's summarize. What did we do? Define the vector, gave examples of vectors, tried to find the magnitude of a vector. Number one, how to add vectors. We looked at that. How to find the difference between vectors. How to take the dot product of vectors. And finally, how to take the cross product of two vectors. That is all the theory that you need. And remember, this chapter is going to be very important, not just for this chapter, because we're going to use this as we continue through the semester. Therefore, for your own good, make sure that you understand this perfectly. And we'll see you on the next video. Thank you.